Once again, welcome back to the Math Revision Made Meticulous video series. Topic Integral, Day 21, Area of Bounded Regions. Revision, as the name suggests, means looking back over previously learned information, ensuring that it is clear and fresh in the mind. 5 questions per day from selected topic is presented at this video series. The steps in answers are supported by the ideas used for getting the answer. Let f of x be a continuous function defined on a closed interval ab. Then the area bounded by the curve y is equal to f of x, the x-axis, and the ordinates x is equal to a and x is equal to b. These ordinates are nothing but the range of x from what number to what number we have to do the integration. And bounded by the x is equal to a is a line and x is equal to b is another line. This area is given by integral a to b f of x dx, which is nothing but a to b y dx. So from the given curve, you have to get the value of y, what is y, and integrate it from a to b. Therefore, to get the area, you have to identify two things. One is what is y and what are a and b. Then suppose if the area bounded by the curve is x is equal to g of y, then it is a y-axis and y is equal to c and y is equal to d. The area will be x dy from integral c to d x dy. You have to be a bit careful in both of them. If the x-axis is involved, it is a to b y dx. If y-axis is involved, it is from c to d or whatever the number from the range of y x dy. Let us go to some problem now. Let us now go to some questions where the function is given, x-axis is mentioned and the lines are given. Now the given equation is like this, but I want y, therefore I have taken y outside from the terms xy and 2y. It will be y into x minus 2 and pushed everything to the right hand side. It is 3x plus 10. For y is 3x plus 10 by x minus 2. Now by the formula, it is very clear that area is integral a to b f of x dx, which is integral a to b y dx. Here a is 0 and 3, x is 3 and x is 4, therefore from 3 to 4. But now this is a problem where we have to divide the numerator by denominator, because this is an improper fraction. For when I divide 3x plus 10 by x minus 2, 3 should be multiplied. It will become 3x minus 6. For the remainder is 16. For I have to put it in the form q plus r by d. Quotient is 3 plus remainder 16 upon x minus 2. Now simple integration. Integration of 3 is 3x and integration of x minus 2 is 1 upon x minus 2 is log x minus 2. When I put 4 as the upper limit, it will become 12 plus 16 log 2. When I put the lower limit, it will become 9 plus log 1. When you do the subtraction, final answer is 3 plus 16 log 2. Here what we have done, a curve is given, from that we got the value of y, and the range of x is already given in the question, x-axis is involved, therefore we simply did from integral 3 to 4 y dx. Now if you want to see, visualize the graph of this, how the graph is there, this is the function, y is equal to 3x plus 10 upon x minus 2, and the strip which you are seeing, that is the area bounded. We also got the value in the previous slide. Let us move on to the next question. Find the area of the region bounded by the curve y is equal to 2 into root 1 minus x square. Here be careful. In some of the problem they will give y directly, or some of the problem they will square both sides. Y square is equal to 4 into 1 minus x square. Then they will give it as a formula of a circle or a ellipse they can give. Well, x-axis is given and the lines x is equal to 0 and x is equal to 1 is given. But we can start directly. This is the area. Area from 0 to 1 from 2 multiplied by root 1 minus x square dx. Here the famous formula of root a square minus x square to be applied. It is x by 2 root a square minus x square plus a square by 2 into sine inverse x by a. This formula will be highly useful in this area bounded by the curve whenever a ellipse and circles are involved. Ellipse and circles are involved. Well, therefore 2 into x by 2. Therefore here a is 1. For x by 2 into root 1 minus x square, a is 1, therefore plus 1 by 2 into sine inverse of x by 1. Now I have to replace x by 1 and then get 1 by 2 into root 1 minus 1 plus half into sine inverse of 1 by 1 minus of, whenever I put x is equal to 0, it is 0 by 2 into 1 plus 1 by 2 into sine inverse of 0. Therefore you get the value at the lower limit is always 0. Therefore 2 into 1 by 2 into sine inverse of 1 is pi by 2. Therefore the answer is pi by 2 square units. Here you have been given the function y directly, and the x-axis is given and the x is equal to 0 and x is equal to 1 is given. We have done the integration. Now this is the diagram for that. Here you have been asked only to find the area bounded from 0 to 1. Suppose all of you know that in the left side also you are getting the same area, but that is from, if it is from minus 1 to 1, then you will get the total area, but it is only in the first quadrant asked in the question. Good. Now let us go to the next question. Sometime they will ask you to sketch a curve and then they want you to evaluate it. Here the modulus function is given, y is equal to mod x plus 3. You have to evaluate minus 6 to 0 mod x plus 3, and they are asking what does the value of the integral represent on the graph. Let us continue. Minus 6 to 0 mod x plus 3 dx. By using one of the property of definite integral, to integrate modulus function we have to equate the f of x to 0, x is equal to minus 3. We have to split the integral at minus 3, because for minus 6 to minus 3 it is minus of x plus 3, for minus 3 to 0 it is x plus 3. For now, we will split the integral into 2, minus 6 to minus 3 of mod x plus 3 and minus 3 to 0 of mod x plus 3 dx. In the first integral, mod x plus 3 is minus of x plus 3. In the second integral, it is x plus 3. Because in the first integral, it is less than 0. In the second integral, it is greater than 0. Now, if I integrate, it is x square by 2. I am taking minus n outside. X square by 2 plus 3x. Once again, x square by 2 plus 3x. When I apply the upper limit, it is 9 by 2 minus 9 minus of 36 by 2 minus 18. In the second integral value, if I apply the upper limit, it is 0 minus 0, lower limit minus of 9 by 2 minus 9. Now it is very simple, 18 minus 9, our final answer is 9 square units. Now your question is asked, they ask you to integrate it, and they are asking you what is the meaning of that integrand. The value of the integral represent the area bounded by the curve y is equal to mod x plus 3, the x-axis, and the ordinates x is equal to minus 6 and x is equal to 0. And you can simply tell that by the line x is equal to minus 6 and x is equal to 0 also. Now this is the diagram once again. Y is equal to mod x plus 3. You are seeing it is a modulus function, and from minus 6 to 0, value of that shaded region is 9 square units. Let us move on to question number 4. Find the area of the region bounded by the curve y is equal to 2x minus x square and x-axis. Here what is the difference? Here we don't know the value of x. From what to what we have to integrate. Very simple. Equate that 2x minus x square to 0. You will get x is equal to 0 and 2. Now you have to integrate from 0 to 2 of the given value, that is the given function, that is 2x minus x square. Integral is very simple. 2x square minus 2 is the integration of 2x, and integration of x square is x cube by 3. When I apply upper limit, it is 4 minus 8 by 3, and when I apply the lower limit, it is 0. Therefore the final answer is 4 by 3 square units. Here what is the difference? Here you have been simply given the area bounded by the curve only, and the x-axis we have to get the value of from what to what. Let us see its diagram. This is the diagram. It is a downward parabola where from 0 to 2, when the area bounded by the x-axis is in the first quadrant, the value is 9 square units. Let us move on to the next question, where we have been given only the curve and the line. Find the area of the region bounded by the parabola y square is equal to 8x on the latus rectum. Now let us recollect what is the latus rectum. The latus rectum is the line segment perpendicular to the axis and passing through the focus. Here the focus is 4ax, therefore the focus is 2, 0, therefore latus rectum passes through 2, 0. This is a diagram for it. Y square is equal to 8x is a parabola having the vertex at the origin, and the latus rectum is a line or line segment passing through 2, 0. What do you have to do now? We have to integrate from 0 to 2 of root 8x dx. And you are seeing in the previous slide that the area is one in the top and one at the bottom. Therefore, the area should be 2 times. For 2 times 0 to 2 of y square is 8x, y is root 8x. For 2 root 2 comes outside, therefore root x. You know what is the integration of root x? It is 2 by 3 into x power 3 by 2. When I apply the, by 2 by 3 also I am taking it out. When I apply the upper limit, it is x power 3 by 2, therefore 2 power 3 by 2 minus 0. 2 power 3 by 2 is nothing but root 8, which is nothing but 2 root 2. By simplifying the constants, Final answer is 32 by 3 square units. Here you are not given the value of x, from what to what you have to integrate. And another interesting thing, here you are getting two parts which are symmetric to each other, one at the top and one at the bottom. You have to multiply it by 2. This is the diagram for it. You are having a region at the above x-axis and you are having a region in the below the x-axis. Suppose in the question they are asking find the area bounded by the curve and the lattice rectum in the first quadrant. No need to multiply it by 2. Success is dependent on efforts. All the best. Thank you.